In the last video, we saw a number of operations we can perform on sets to produce new sets that fit different kinds of real situations. In this video, we're going to introduce another set operation that's similar to these, but it's different and needs a little more explanation. Let's go back to our fictitious discrete math class. Suppose the class is met a total of 10 times and the instructor wants to look at attendance at class meetings. So she creates a spreadsheet with the names of students in one column and the number of days they have attended in the other. This pairs off each student with a number. We can think of these pairs as an ordered pair, like this. Remember that U was the set of all students in the class, and the numbers here could range between 0 and 10 since the class is met 10 times. Let's let A be the set 0, 1, 2, and so on through 10. The set of all possible pairs that the instructor could create, with students in the first slot of each pair and integers 0 through 10 in the second slot, is called the Cartesian product of U and A. In general, given any two sets A and B, the Cartesian product of A and B is the set of all ordered pairs that have the first item in the pair coming from A and the second coming from B. We use a cross, like you might see in primary school, to denote multiplication of two numbers as the notation. For example, look at the set 1, 2, 3 and its Cartesian product with the set AB. This is the set of all ordered pairs whose first coordinate is in the set 1, 2, 3 and whose second coordinate is in the set AB. There are 6 such pairs, and here they are. There are 2 pairs for each of the 3 elements of the set 1, 2, 3. 1A and 1B, then 2A and 2B, and finally 3A and 3B. In our classroom example, the product of U and the set 0 through 10 is the set of all possible pairings of students and attendance. So there are 11 possible pairs for every student, making this a pretty large set. The pairs that are in the instructor's spreadsheet would just be a subset of the entire product, but definitely not equal to it. Now you try it. Write out the set A times B, where A is the set XY and B is the set 1, 2, 3, 4. You should find there are 8 pairs in this product, and here they are, 4 pairs for each element of A. Or, to think about it another way, there are 2 pairs for each element in B. Notice that unlike in multiplication of real numbers, the order of A and B in A times B matters. In the example you just worked, B times A would be this set. It's still got 8 pairs, but the ordering of the coordinates is reversed. These are ordered pairs, so x comma 1 is not considered to be the same thing as 1 comma x. So these two sets have the same cardinality, but the elements themselves are not the same. You've actually worked with Cartesian products before because you've worked with ordered pairs before. Back in your early algebra classes, you learned how to plot points in a 2-dimensional xy plane and then graph functions using this process. Each point is a pair of numbers like 4, 3 or -2, -3. So the xy plane consists of all those points. It's the set R times R, where R is the set of all real numbers. This is the set consisting of all possible pairs with real numbers in each coordinate. So you've learned what the Cartesian product is and how to find the Cartesian product of simple sets. In our next video, we'll be shifting gears to focus on the idea of a function, which, as we just mentioned, is a way of mapping elements of one set onto the elements of another.